Good morning. I am D. Sengotain, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today our case study topic is semiconductors, that energy band diagram of semiconductors. So in semiconductors, the gap in between valence band to conduction band, that means band gap energy or barbiton gap energy or energy gap. So normally in conductors, the energy gap in between valence and conduction level is very low. Then in semiconductors, it lies between conductors and insulators. So we all know that insulators having large amount of band gap in between valence to conduction band. Then the first table shows that band gap energy level of some intrinsic materials, for example silicon 1.11, germanium 0.67 and gallium arsenide 1.42. So these are the example for some intrinsic semiconducting band gap. Then the table shows that at 0 Kelvin all the semiconductors behave as insulators. So the first diagram shows that at 0 Kelvin fully filled valence band, that fully filled with electrons, then the empty, almost empty conduction band. So then gap in between valence to conduction is called band gap energy. If the temperature increases, one or few electrons gain energy from the temperature, then moving from valence band to conduction band, that is called electrons moving from valence to conduction band. If electrons moving left to right direction, then the holes moving directly opposite, right to left direction. So in semiconductors, the energy or energy band gap, the conductivity totally depends on holes and electrons, the charge carriers Nd and N-gauge. So we are going to study about very simple value of density of electrons in conduction, then the density of holes in valence band. Then the next variation of Fermi level with the temperature, then variation of Fermi level with the temperature, and finally carrier concentration in intrinsic semiconductor. These all are the important lines about intrinsic carrier concentration. Then this diagram shows that the gap in between insulators, conduction band and valence band, it is more than 3 electron volt, that is called insulating materials. So next our CSE B students explain about the importance of semiconducting materials and its applications. Thank you.
Good evening to all. Semiconductors. Semiconductors are backbone of our electronics because it is used in day-to-day applications like wearables, smartphones, tablets, and various other electronics. It is used in consumer electronics as a microprocessor. Many of the innovations like AI and the cloud, AI and quantum computers are only possible with the help of pushing the limits of silicon. Silicon is rather used as a semiconductor. It is also used in communication things. Like in our day-to-day life, we are using 5G. It is capable because of the innovation of semiconductors and pushing the limits of semiconductors. We could access various different types of technologies. Like at present, every mobile has an usage of 5G. It is possible because only of the improvement of semiconductors, which is rather used as a microprocessor in our phones. It's also used as a microprocessor in many other devices, like day-to-day life. We are using washing machine. It is also made as an automated thing. It is achieved with the help of a semiconductor which is present in the transistor. And it is also used as an engine control unit, which will control the fuel injector present in the engine. And it is also used in applications such as ADAS, which is an thing which is only achieved with the help of semiconductors.
Its connectivity can be controlled by docking or temperature, making it useful in electronic devices like chips or transistors. In semiconductors, there are two types. One is intrinsic semiconductor and then extrinsic semiconductors. In intrinsic semiconductors, it's a pure conductor like silicon. In extrinsic semiconductor, it's the doped semiconductors and it has the two types: N-type and P-type. Semiconductors, there are two types. One is N-type and P-type. In N-type is extra electrons due to top-weight elements like phosphide and it carries the negative charge. And another one is P-type, extra holes due to top-weight elements like boron, it carries the positive charge.
second most disadvantage, it involves making of many chemicals and residues. So disposing of a chemical which is used to create transistor makes it difficult to dispose that chemicals, and to make other advantages of